Okay, so in this question, you were being asked about John Dalton and how it's different from today's model. If you remember, John Dalton described atoms as just solid spheres, and we didn't have any nucleus or any subatomic particles. So that's going to be the main focus of our response. Where we know nowadays, you've got the central nucleus, and then you've got your energy levels with the electrons, and that nucleus has got those protons and neutrons inside it. So to get the marks for this one, the differences between it are we now understand that atoms contain subatomic particles, and Dalton didn't have that. The other thing we could say in here, if you want something a bit different, is that we know that isotopes exist because they have different numbers of neutrons, and Dalton hadn't identified that situation. Okay, give the molecular formula. So this is the molecule. So all I have to do here is count the number of atoms inside this formula. So I've got 1, 2, 2 lots of carbon, and then 1, 2, 3, 4 lots of hydrogen. To find the empirical formula is the simplest ratio. So if I divide these by 2, I can get down to CH2, and that is the simplest ratio, and therefore the empirical formula. Okay, the next one is a reaction. We've got to write a word equation for it. So it tells me that chlorine gas is reacting with water. So let's put chlorine in. So chlorine is Cl. Remember, it's diatomic, so it's 2. And water is H2O. And it says the products are hydrogen chloride and this substance HClO. Well, they've already put HClO in the equation here. So anything we've got missing is hydrogen chloride. Hydrogen chloride is HCl. If you don't remember that, if you go to your periodic table, you know that hydrogen is a positive ion and it wants to make one bond, and a chloride ion is a negative ion and it also wants to make one bond. So when you cross those over, hydrogen gets a 1, chlorine gets a 1, so it's HCl. Now in terms of state symbols, we're told here that hydrogen is a gas. So let's put that hydrogen is a gas into the equation here. Water, we should hopefully know, is a liquid, so I'm going to put L in there. Hydrogen chloride, it tells me, is a solution. So if I've got a solution, we are talking about aqueous. Marks wise, if you've got the chlorine and the hydrogen, you get a mark. If you've got the state symbols correct, you get another mark. And this side, you get another mark here for HCl. Give the formula for the ion that makes hydrogen chloride to be acidic. Hopefully remember that to be acidic, you need H plus ions. Acid reacts with an alkali, give the name. So when they react together, it is a neutralization reaction. And the final one is describe what you'd see when copper carbonate is added. So when you add a carbonate to an acid, you are going to get bubbles produced as carbon dioxide forms. So the first thing I'm going to write in here is it would fizz as a gas is released. Now there's 2 marks, so I'm not going to get both marks for that. The other thing that we'd see is the copper carbonate that we added powder would disappear. So the copper carbonate powder would disappear. So I'm going to put in here that the powder would disappear as it reacts. 1 mark for each of those.